Good evening, dear 11th standard students. Welcome to this standard 11th. Congratulations for your completion of 10th standard and welcome to the standard 11th. You have made the decision to learn this stream of science, and I am here, Dhanu Saraiya, with the subject physics available for you. Correct? Today we will do the chapter number 1, part 1. Okay, which is units and measurements. Fine. Now let us first of all understand what is the available topic in this chapter: units, measurement. So when we talk about measurement, we definitely have one quantity to be measured and one quantity or one available amount of comparison with us. Let me give you a simple example. You have gone to the shop to purchase 1 kg of, say, some vegetable, tomatoes. Okay. Then what will the person or what will the shopkeeper do? He will take a certain amount of tomatoes. He will put it in a basket and compare it with 1 kg of the measurement he has and say, fine, this is your 1 kg of tomato, take it. What does it mean? It means that whenever you want to measure any quantity, it should be a measurable physical quantity. That measurable physical quantity is a comparison. As I said, it is a comparison of certain value you have in your hand. That comparison is basic. It is arbitrarily chosen by the world. That's why internationally accepted. You take 1 kg of stone, 1 kg of measurement in India or abroad, anywhere, it is going to be 1 kg. Fine. So these are the words, keywords which you have to remember when you want to measure any physical measurable quantity. What are the words? Comparison, as I said, with basic, arbitrarily chosen. Arbitrarily chosen is just chosen. One fine day it was chosen. Yes, this will be accepted internationally. So it is accepted internationally. Scale, accepted internationally. Correct? And reference standard for unit. It is a reference for the unit. 1 kg, half kg, it is a reference. It is a comparison. It is chosen. It is internationally accepted. It is arbitrary. All these words have a meaning which I just explained. So, to measure a quantity, we require its unit. Correct? We represent it by unit. Now, how many physical quantities are there? Many. So, we will go on differentiating the physical quantities and their units, and there will be so many units to be remembered then. So, one easier solution was considered, that we will consider some fundamental units or some basic units. So, some basic units required for measurement are called as fundamental units. So, some basic quantities are taken and their units are considered as fundamental units. So we have fundamental units that are, I'll write in short, that are the units of basic, fundamental, physical quantities. We will learn about these fundamental units elaborately once we finish the introduction part of the types of the units. Fine. Now, using these fundamental units of the basic physical quantities, we will derive or we will form the units of other physical quantities. So, what are those quantities called? derived units. So the combination of these basic units are called the derived units. I have written it in short. Now the combined units of fundamental units plus derived units is called as system of units. Okay. So in olden days, many system of units were introduced, taken into consideration, then they were removed due to some difficulties or the other. So we will just go through in short what was the system, what were the system of units in ancient days, and then we will come to what is the system of units used today. Fine. So basically there were three systems of units which were used in ancient time. One, FPS unit, full form foot, pound, second. What were the physical quantities measured by these units? Foot was the length, pound was the physical quantity mass unit, and second was the time, which was measured by seconds. This was the ancient system of unit. Next, CGS. Considering the same physical quantities, centimeter, mass in grams, and then time in seconds. Third, same physical quantities, length, mass and time. Third, MKS, which is meters, kilogram, second. All these systems had some difficulties in using, and the main difficulty was the conversion factor, using it from one country to the other country. These were the basic limitations of such systems. So today we are using international system of units called SI units, which we are using today. Okay, so under these SI units there are 7 fundamental units. How many? 7 fundamental units. Yes. So already as discussed, there are 7 basic fundamental units. Fine. In the textbook there is a column which is just explaining you about those base units, and their definitions also are there. Here I will just give a short quick follow up of whatever is given in the table, and then we will go to additional 2 more units which are added to the 7 units, right? So these are the 7 fundamental units which are tabulated in your textbook, and you have to learn the definitions. Here I will just give you a follow up of what are those base units. Okay, the first one is the length, which is having a unit of meter, and the symbol is M. Second one is mass, having the unit of kilogram, symbol is kg. Third one is time, having the unit of second, symbol is SEC. Fourth one is current, having the unit of ampere, symbol is A. Fifth one is temperature, unit is Kelvin, having the symbol of K. Sixth fundamental unit is amount of substance, having the unit as mole, and the unit is the symbol is MOL. And the last one, the seventh one, is luminous intensity, having the unit of candela, and its unit is CD. Okay, so all these symbols and units are the basic units. Using these units, we can formulate the derived units as discussed already. Okay, now other than the 7 fundamental units or the base units, there are 2 additional units. Those are plane angle and solid angle, which we will discuss right now. Now, plane angle is drawn as a part of a circle as shown here, where it is symbolized as d theta. Okay, and this is the, if I complete this circle, this is the radius, this is a part of the circle, and ds is the arc, length of the arc. So remember that plane angle is a part of the circle, where d theta is the plane angle, r is the radius of the circle which you are considering, and ds is the length of the arc. So I will just write down its formula. D theta is equal to ds upon r, where r is the radius of the circle and ds is the length of the arc which we have considered. And the unit of d theta, unit is radians. Name is radians, and it is denoted as RAD. So we will use this formula in the numerical. Okay, you can remember the unit as radians. Fine. So remember that plane angle is a part of the circle, and the angle is made at the center of the circle with the radius. Formula given is d theta is equal to ds upon r, where r is the radius of the circle which you are considering, and ds is the length of the arc which you are considering. Its unit is radians, short form is radian, that is symbol is RAD. Fine. Okay. Then is a solid angle, which I would like to explain it with a small example of a cone in my hand. Consider a sphere, and the sphere can be considered as cones, correct, with the center. So this is our solid angle. Okay, and the angle, this is a part of the sphere, and the angle is this part, the central part. Are you understanding? The central part of the cone, that is the angle. Fine. Now we will define it. First of all, we will draw it and understand what is a solid angle and relate it with what I am showing. I am showing that the angle of, or the solid angle, is the central angle which is the lowest part of the cone, or which is a vertex of the cone. Fine. So I have drawn the part of the sphere on the board like this. You can imagine it, and I will teach you also how to draw it, because in the exam drawing it will or may become little bit difficult for you. So I have just drawn 3 line segments, as you can see. Then with that yellow portion, I have just made a circular arc shape for both of them. And then I have again drawn 2 portions of arcs and I have drawn a dotted line. Now where is the solid angle? That is our query. So how to draw the solid angle is start from the uppermost part, go to the dotted line, then come to the next part which is a solid line, go back to the solid line and then complete the rhombus shape or a quadrilateral. So here it is the quadrilateral, which is the solid angle denoted by d ohm. Okay, r is the radius of the sphere which we have considered, and dA is the intercepted portion of the sphere which was intercepted by that cone. Fine. So the formula of d ohm, which is the solid angle, is given by dA, the intercepted area by the cone which we are considering, upon r square, the radius of the sphere. Fine. Where dA is the intercepted area of the sphere which we are considering, and r is the radius of the sphere. Okay, unit is steradians and its symbol is SR. So this is another formula which you have to remember, and its unit is steradian, which is short form SR. So now you have to remember that there are 7 fundamental units which I explained in the table, and 2 extra units which are plane angle and solid angle. Plane angle is the part of a circle at the center of the circle, given by d theta is equal to ds by r with the unit radians. Similarly, solid angle is a part of a sphere given at the center of the sphere, denoted by d ohm, which is equal to dA upon r square, where dA is the intercepted area of that sphere, that part of the cone, and r is the radius of the sphere. Unit SR, formula d ohm is equal to dA upon r square. Fine. So I will just move now and you take the screenshot of whatever is being taught. Slowly and steadily we can aram se learn these chapters without any fear or without any type of a question mark that will I be able to do it or no. You like it, you have taken the stream, so you will do it at your best. Fine. Take the screenshot.